Hello everyone. Welcome back to SHR Trinity. Welcome back to our prompt engineering interview series. In the previous video, we covered the fundamentals of prompt engineering and some essential beginner interview questions. In today's video, we'll move to the next level with more intermediate questions, exploring crucial topics like context window boundaries, the lost in the middle attention phenomenon, parameter tuning with temperature and top P, mitigating hallucinations, and cross-model prompt sensitivities. These questions will strengthen your understanding and prepare you for real prompt engineering and generative AI interviews. If you're looking for practical, hands-on training in generative AI, prompt engineering, RAG, agentic AI, Langflow, MCP, and chatbot development, explore our 30-hour comprehensive generative AI training program. You can find the course details in the description below. Now, let's continue with today's interview questions. We are also excited to announce the Generative AI Comprehensive Hands-On Training Program by SHR Trinity. This is a 30-hour intensive course featuring 20 live sessions of 1.5 hours each, held Monday to Friday from 7:30 p.m. to 9 p.m. The curriculum covers Python, transformers, prompt engineering, RAG pipelines, autonomous crew AI agents, Langflow workflows, and model context protocol. To enroll or learn more, contact us at contact@shrtrinity.io or call us at +91 70956 78789. We will now begin with the next 10 questions of our prompt engineering interview series, covering questions 11 to 20. Question 11. When using few-shot prompting, how do you select and structure the examples? How many examples are usually optimal? When structuring few-shot examples, I select diverse, representative samples that cover edge cases. The structure should mirror the actual task exactly: input, data, thought process, if needed, output, result. I separate examples using clear boundaries. Usually, 3 to 5 high-quality examples are optimal. Beyond 5, we see diminishing returns in accuracy while significantly increasing token latency and costs. Question 12. What is the context window limit of an LLM, and how does lost in the middle affect how you organize information inside a long prompt? The context window is the maximum number of tokens a model can process in a single request, input plus output. The lost in the middle phenomenon is an attention bottleneck where LLMs recall information at the absolute beginning or the absolute end of a long context much better than information buried in the middle. Therefore, I place critical rules and core instructions at the very beginning and key constraints/output formats at the very end of the prompt, leaving raw reference documents in the middle. Question 13. How do temperature and top P differ mathematically in controlling token generation? When would you use both together? Temperature scales the raw logits before they are converted to probabilities. A low temperature sharpens the differences, making high probability tokens even more dominant, while a high temperature flattens them. Top P, nucleus sampling, limits the token selection pool to a cumulative probability percentage, e.g., top P of 0.9 means we only consider the top tokens whose combined probability equals 90%, discarding the bottom 10%. I do not usually tune both heavily at the same time. The standard practice is to keep top P at 1.0 while adjusting temperature, or vice versa, to avoid unpredictable output degradation. Question 14. What are AI hallucinations? How do you write prompts to mitigate them in a production system? AI hallucinations occur when a model generates plausible sounding but factually incorrect outputs. To mitigate this in prompts, I use 3 main strategies. 1. Grounding. Instruct the model to answer only based on the provided reference text. 2. An escape clause. Explicitly prompt, if the answer is not present in the provided context, output I do not know. Do not speculate. 3. Citation requests. Ask the model to quote direct sentences from the context that support its answer. Question 15. What is context engineering? Explain how you would optimize a prompt to save API token costs without losing accuracy. Context engineering is the practice of structuring and trimming context data to maximize model comprehension while minimizing token footprint. To optimize costs, 1. I remove redundant conversational elements, boilerplates, and repetitive headers. 2. I use compact formats like CSV instead of verbose JSON/HTML in the prompt context. 3. I use prefix caching strategies by keeping static system instructions at the very beginning so the API cache can reuse them. Question 16. How do you build a dynamic prompt template in a codebase? What tools or patterns do you use to inject variables? A prompt template is a reusable shell where static instructions are defined, and placeholder slots are left for dynamic inputs. In Python, I use Python's built-in string, template or formatting dictionaries, or templating engines like Jinja 2 for complex logic, loops, conditionals. In LangChain/semantic kernel, I use their native prompt template wrappers. This ensures that user data is sanitized and safely injected into the preconfigured system rules before calling the LLM API. Question 17. What are negative constraints? Why do models sometimes ignore instructions like, do not mention pricing, and how do you fix it? Negative constraints instruct the model what not to do. LLMs sometimes ignore, do not. Instructions because of attention bias. Mentioning the word pricing activates tokens related to pricing in the model's semantic network. To fix this, I rephrase negative constraints into positive execution rules. Instead of saying, do not discuss pricing, I say, focus strictly on technical features. If the user asks about pricing, redirect them to our sales team at contact@sales.com. Question 18. How do you compare ChatGPT, Claude, and Gemini in terms of prompt sensitivity? Do you write prompts differently for them? Yes, prompts should be tailored. GPT models, ChatGPT, are highly receptive to direct markdown headings, structured lists, and explicit system instructions. Claude, Anthropic, is optimized for XML tags, wrapping context in doc, and instructions in instruction that dramatically improves its parsing accuracy. Gemini, Google, excels at multimodal processing and behaves best when instructions are highly structured with explicit context grounding. Claude is also much better at adhering to complex multi-step rules in long prompts. Question 19. If a model outputs trailing conversational filler like, here is the summary you requested when you need clean text, how do you eliminate it? To eliminate conversational filler, I use a combination of strict instructions and few-shot examples. In the prompt, I specify, output only the raw summary. Do not include introductory phrases, pleasantries, or explanations. I also provide two few-shot examples where the output block starts immediately with the summary text. For API calls, setting system prompts or utilizing JSON schema output features natively stops conversational filler. Question 20. What is few-shot class imbalance, and how does providing biased examples in a prompt affect the model's classification output? Few-shot class imbalance occurs when the examples provided in the prompt are heavily skewed towards one class, e.g., providing 4 positive sentiment examples and only 1 negative example. This biases the model's output probabilities, making it much more likely to predict the majority class for ambiguous inputs. To prevent this, I maintain absolute class balance, e.g., 2 positive, 2 negative, 2 neutral examples, and ensure that the order of examples does not establish a repetitive pattern. Thank you for watching. If you found this video useful, please subscribe to SHR Trinity, click the like and share buttons, and stay tuned for the next part of this series. If you are interested in attending our live training sessions or have any inquiries, all our contact details are displayed right here on screen and are also available in the description below. Feel free to reach out to us. See you in the next video.